Hello, everybody. Welcome to another day in Coach Wallace's Algebra 1 class. Okay, so today we're going to extend upon, we unpacked the standard last class. So it was A.SSE.1, and our learning target today is we're going to factor out the greatest common factor from the terms of a polynomial. Okay, so we know we unpacked the standard last class. We should know how to go about finding a GCF with both numbers and variables. So let's extend it to a polynomial, which is a many-termed expression. Okay, so remember our steps for finding the GCF of a polynomial. First, we got to factor the common term, or we've got to do a common factor of each term by using the ladder method. So we learned this last class, we'll extend upon it. For each number, we want to determine the smallest prime factorization. So start by dividing out small numbers from each common term. And then for each variable, as long as they have a common variable, we want to make sure we take the variable with the smallest exponent. So we're looking for small things. Okay, then step 4, after we do each number, each variable, then we want to repeat the numbers if we can. We should be done with the variables. So can we continue to divide these numbers by small prime numbers? At the end, once we have all these, the smallest things we can divide out, if there's more than one number, we want to multiply to get that coefficient for the GCF and then combine it with the variable, okay? And at the end now, we're going to extend this to a polynomial, is we take the GCF and we put it outside parentheses. Inside of our parentheses, we put what's left over, what's the remainder, okay? And then that's how you properly factor a polynomial. All righty, so let's start with example 1. And remember, this is the I do portion, which is what I will do with the class. All righty, and then I will provide you a you do, which you will do on your own, and I will help guide you through it. If you need some guiding questions, all righty, we will summarize with an exit slip, and I will let you guys get out of here for the day. Sounds good? Let's start. Example 1, everybody. So remember, we did numbers, we did variables. Let's extend it to a polynomial. We'll start with a nice small 2-termed polynomial, which is a binomial. Remember, what separates our terms are plus and minus signs. So let me put a little space there so you don't get confused. So let's do negative 6x. I'll write the exponent to the second power. And then now we're going to separate it with a second term, minus 36x to the power of 4. Okay, let me build this up a little so I can draw. Okay, so the first term has a 2 for the exponent of x, and the second term has its 4. Okay, so let's factor this properly. Alrighty, by doing the GCF. Okay, so the ladder method. How do we do this again, class? Okay, good. We write the terms off to the right. So we got negative 6x squared. And then we got a negative 36x to the 4th. Good. All right, so, all right, good. And we write our first step in the ladder. All right, so somebody tell me, how do we work with the numbers? Okay, good. We want to start with small prime numbers to divide them. Good, 2 goes into evens. So we got this 6 and we got 36. And remember, it's important if they're both negative, we want to take out the negative. So negative 2 is the smallest prime that we're going to divide these by. Good, everybody. So what do I do next? Okay, I write what's left over after you divide each term. So negative 6 divided by negative 2, everybody, what do we get? 3, good. Negative 36 divided by negative 2, everybody? Positive 18, good. Okay, what do I do next? Bring down my variables, good, because we're going to work with them next. So we got x squared and x to the 4th. Okay, good. Alrighty, and then good, we write our next ladder step. Okay, so let's work with these variables. Are they a common x? Good, I hear somebody says we got a common x. Which one do I take? 2 or 4? Smallest, everybody, good, 2. Okay, so now what do we do with the variables when we take out a factor? Subtract, I hear, good. So let's bring down the numbers, we didn't mess with them, 3 and 18. All right, so if we have 2 x's here, and we take away 2, do I have any left, class? No, none left, so nothing to write. How about this 4? What do I have left when I take away 2? 2 of them. Good, everybody. Okay. Am I done? No. Good. Who said that? Gage. Good. Gage says no. I can take more out of the numbers. I'm going to keep drawing another ladder set. So how much can you take out? Good. I can divide 3 and 18 by 3. Good, Gage. So I'll put a 3 out here. 3 divided by 3, everybody. What am I left with? 1. 18 divided by 3, everybody. 6. Good. And then don't forget our variables to bring down. X squared. Okay, am I done, class? Good. Once you get a 1, we should know we're done, and then there's no more common variable. Okay? So, tell me, how do I get the GCF now? Good. Somebody new. We take the numbers to the left, and if there's more than 1, we multiply them, and then we combine them with the variables for coefficient variable combination. So, -2 times 3, -6, and then don't forget that x squared. Good, everybody. There's my GCF. Good. That's what we practiced last class. Okay. So let's add that extension of what we now do with this polynomial to properly factor it. We said we leave the GCF on the outside of parentheses to the left. We take the remainder, what we had left in our ladder, which should be on the bottom, and we write each term in the parentheses. So good. We got 1, and we got this 6x squared. Good, everybody. Let me hear from somebody new. What do I need? I like it. You can't forget when there's more than one term, we need to separate them with a sign. So what is the sign of 6? Positive. Good. Okay. Now a way to check, everybody, to determine, because this is the proper answer for how you factor the polynomial, is we can use distributive property, which we should know. Multiply what's outside the parentheses by what's on the inside. We have 2 multiplications. Can we get back to this original? And that's how you can check. So -6x squared times 1. Well, anything times 1 is itself. So you get -6x squared. And then -6x squared times 6x squared positive. So -6 times +6 is -36. X squared times x squared, we should know when we multiply the same variable, they're both x's, that we add these exponents. So 2 plus 2 gets us 4. And what do you know, class? We're back to that original problem up here that we started with. So we know that this is our proper answer. GCF on the outside, remainder on the inside. Any questions? No, I don't hear any. Good. I feel like that made sense. The light bulb clicked. Okay? Alrighty. So that is the teacher-led portion. And I'm thankful that y'all helped guide me through it. Alrighty. So now let's provide one for you to try individually. And then we'll come together after the music ends. Okay? Alrighty. So at this point in the lesson, I would write a problem, which I will give in a second. I allow the students to work individually on it. Alrighty. But I also let them ask me questions as I revolve around the classroom. And then if there are students online, I might do breakout rooms in Zoom and then check in each breakout room. So they're not really communicating with other students. They're working individually. Alrighty. So what I like to do in my class, it might be different with online, is I set the timer for, I give them probably 5 minutes to work on a problem. And I play music during this time because the students know that when music is playing, it's their turn to, you know, work. And if they are in groups, communicate and collaborate. But when the music stops, it's, you know, let's all come together and have Coach Wallace give them our attention, and then we get to work on the problem. Okay. So after the 5 minutes, I will then get some volunteers to answer. If I'm not getting any volunteers and they're hesitant, then I have on my phone a nice random name generator, which I try not to use because I don't like to cold call on students. I don't want them to get fearful. They already are of math. So I do like to have volunteers, but if it's the same people each time, then I'm not afraid to use that, or if I'm not getting any input. Okay, but after I give them the you do individually, I do have them step by step. I act like, hey, well, what do I do next step? So I have them guide me through the whole process of how to do it. Okay, so I'll do that now, and I'll try to do it shortly. Okay, so let's do another whiteboard. Let's clear there. And then we'll say that the music just ended. Okay, so we'll say, okay, class, let's come together. Music just ended. Example 2. They had 15x to the 7th minus 20x to the 6th plus 10x to the 5th plus 25x to the 3rd. And it's just easier for me to write in these variables. So this was 7, 6, 5, and 3. Okay, so I'd say, okay, class, what's the first step? And then I should have somebody say, hey, let's write them off to the side so we can do the ladder method. And there's 4 terms, so we need to write all 4 of them. So we got 15x to the 7th, this is faster, minus 20x to the 6th, plus 10x to the 5th, plus 25x to the 3rd. Okay, so I have them do it, and then I should say, what do I do? I should say, draw the ladder. So I go boom, oop, I didn't do the free form. But here's our ladder. Alrighty. And then I should say, okay, let's start with the numbers. And then I'll call on a student, or I'll get a volunteer. 15, 20, 10, and 25. So could I do 2? The class should say no. And I said, why? Well, for 15's odd, and you can't divide odd by 2. So then I'd go to the next prime, 3. 15 can be divided by 3, but 20 can't. So no, not 3. Then 5. You should say yes, and I'd ask why. And the class, I teach the class that anything that ends in 5 or 0 is divisible by 5. So 15, 5, 20 to 0, 10 to 0, 25 to 5, all can be divided by 5. And they're all not negatives to do positive 5. Okay, so then I bring down what's remaining. The 15 should have a 3, and we'll bring down the x to the 7. 20 is negative 4x to the 6. 10 is 2. X to the 5th, 25, 5x to the 3rd. Okay, and then I say, all right, what do I do next? And they should say, do the variables, which are your next step in your ladder. Okay, so then let's do the variables. I should say, okay, everybody, is there a common variable between all 4 terms? They should say yes. Should say x. Call on somebody or get a volunteer and say, well, what do I do? Do I take the biggest, the smallest, which one? And they should say, we'll take the smallest one, which is 3. So x to the power of 3. And I say, okay, how do I write what's remaining? And then I should get a volunteer that says, bring down your numbers. So the 3, the negative 4, the 2, the 5, 7, but for each variable, they should say they subtract. So 7 minus 3 is 4. The 6 minus the 3 is 3. The 5 minus the 3 is 2. And then that 3 take away 3, I should just have the coefficient 5 left. Okay, and that's it. Okay, class, good. What do I do next? And then somebody should say you should try to see if you can take more from the numbers. But 3, -4, 2, and 5 don't have any more common factors other than 1. We don't use 1, so I'm done. And then I'll say, okay, if we're done, how do I finish writing this answer? What they should say is that this is your GCF on the outside. So 5x to the third, and it goes outside the parentheses. The remainder is the 4 terms underneath, and they go inside the parentheses. So I should have this 3x to the fourth minus 4x to the third. This 2x squared is positive, so plus 2x squared. And then that 5 is positive, so plus 5. There's my remainder in the parentheses, GCF on the outside. I should say, okay, good, I like where we're going. How could I check? And then somebody should say, well, you can get back to this original problem if you distribute. And when you distribute the 4 terms, or to the 4 terms, you do get back to the original, which is the way to check. And that's the end of the portion of the you do. I should then transition to the we do portion, which is for today's lesson. And what I like to do is rally coach. Okay, and so how the rally coach lesson works is I pair them on ability. So I take a high and a low level. For example, Elijah's advanced, Alexis is low. Pair them together. Or I'd have some medium ability, so like Alicia and Braylon. All right, and I make sure to take into account that they work well together, and also like a male and a female, because they generally are not good friends, best friends, whatever, and they won't get off task. Okay, so how the rally coach activity will work for today is they partner up, A and B, partner A and B. Partner A is going to solve the problem. Partner B is going to coach them. And me being a coach, I really like things where kids can coach each other, my students, and then they have a little bit more accountability. They're able to teach each other, which I think is the best way to learn. And so as A is solving the problem, B is coaching. They're checking that accuracy, making sure they're doing step by step the way that I've taught it. They're providing praise when they're doing it right, which is important. So I need to definitely model how to do that. If they are incorrect, they need to be good with their feedback and coach them properly on how to get that correct answer, okay? When they're done, they get a sign off from me. They show me how they're doing it, how they're coaching, and then they switch. So B goes to solving, A would go to coaching. And that's how the we do. That's how the we do portion works. At the end of class, I like to get a form of assessment that is formative. Hey. Okay, so I generally provide an exit slip, which would be one problem. I like to use my Plicker cards, which are, they have A, B, C, D, and it's hard for the students to be able to copy the answer. So it is multiple choice, which isn't my favorite form of assessment, but it's a way to get quick, instantaneous feedback. And so what I do is, as the students are leaving class, I have my smartphone out and I can, scan the class, get all the right answers or wrong, hopefully all right. It gives me that instantaneous feedback. I provide a threshold at about 80% on the whole class. If we are above that, I know we got the lesson. If we are below that, then I know I need to reteach the next class or, expand further upon it. And that's generally how my lesson works. Thank you.